Welcome back, guys, with your host Josh, and welcome back to Networking 101, where we talk about all things related to networking. So, in today's episode, we're going to talk about the OSI model. I know in previous episode we talked about layer 1 and layer 2 being the physical layer and the data link layer. But in today's video, we're going to go ahead and talk about all the rest of the layers. We'll dive more in depth and we'll see what they're all about. But let's get started. So for today's video, I would like to take a quick break and thank Explain Everything platform, because this will allow us to use their platform in order to explain the OSI model further in detail so you guys can see exactly what is going on. Quick shout out to them. So first, we got to understand what the OSI model is. So it stands for the Open Systems Intercommunication Model. And within that model has all of the layers that make up a network, and they connect other networks within each other. They're able to communicate with each other because of this set system, this model. Okay, so like I said, the first two layers we talked about in a previous video, the physical layer and the data link layer. If you guys want to go ahead and check those out, go ahead and go on to my previous video and you can learn all about that. But right now, we'll talk about the network layer, which is the third layer, and we'll go up from there. So with the help of Explain Everything platform, we'll go more in depth with the network layer right now. So the network layer, as seen right here, is pretty much where all the routing takes place. Now, devices that you can find here, of course, are routers and sometimes multi-layer switches, but the router's main job was to get packets from one network or device to another, and this is all within that layer right there, the network layer. The network layer also has an IP address that is stored within the routers. So you can have IP addresses, also subnet goes in there with the IP addresses. So you'll be talking about subnetting. You'll see that number after the IP address. You'll see like /24 or 25. And you'll also see something called the ACLs, which is the access control list. But the network layer's main concern is being able to send data from one network to another. So that's the main objective of this whole layer. That is what it does. If there's any issues when it comes to IP addresses or any kind of other network issue, then you would go into this layer and start troubleshooting. And so that is the network layer, layer 3 explained. Now we'll move on to the next layer, which is layer 4. We'll dive right in and talk more about layer 4, which is the transport layer. So think of the transport layer as a bus. Now a bus has to get all of its occupants, everyone inside, to the destination carefully and at the same time. So if you think of the transport layer as a bus, that's pretty much what it does. Now the transport layer mainly uses TCP. Now TCP is the transmission control protocol. This is the most widely known protocol used in transport layer. It is used for connection-oriented transmissions, whereas like UDP, which is the user datagram protocol, is used for simpler messaging transmissions. TCP is more complex, and it's more reliable for transmission and data stream services as well. Now, other protocols found in the transport layer would be the DCCP, which stands for the Datagram Congestion Control Protocol, and the SCTP as well, which stands for the Stream Control Transmission Protocol. But like I said, the transport layer, its main objectives is delivery of the data, congestion avoidance, its flow control, and its reliability as well. Those are the main features that are found within this layer. So there you have it. Layer 4 of the OSI model is the transport layer. We went over all the advantages of it. We went over what it does. Now next up, we'll go over the 5th layer of the OSI model, which is going to be the session layer. Now, the 5th layer of the OSI model is the session layer. This layer is responsible for maintaining, opening, closing a session between end users and between inter-host applications as well. Now, these sessions consist of constant requests and responses between applications, and what this layer does, it pretty much makes sure that these are being met throughout the whole entire proximity of the connection. An example of a session layer protocol that is found within the OSI would be the Sweet Session Layer Protocol, which is also known as the X.225. Just write it here for you, X.225, or also known as the ISO 8327. So what this protocol does is, in case there is a loss in connection, this protocol tries to recover that connection. So let's say you're using like FaceTime or whatever, and you lose your connection, this protocol will attempt to reconnect you with the other user as well. All right, let me just erase this real quick. Now, other protocols that are found within the session layer would be the ZIP protocol, which is the Zone Information Protocol, as well as the AppleTalk protocol, and the SCP protocol, which is the Session Control Protocol. So basically, an overview of the session layer would be that it provides authentication, authorization, and restoration of connections between two different users or sessions. Great. Now that was the 5th layer of the OSI model, which was the session layer. Next, we'll go over the 6th layer of the OSI model, which is the presentation layer. Now, the 6th layer of the OSI model, the presentation layer, is mainly responsible for the delivery and formatting of information to the 7th layer, which is the application layer. So pretty much the 6th layer is comprised of 2 sublayers, one of the layers being case, which stands for the Common Application Service Element, and the SACE, which stands for the Specific Application Service Element. All right, now found within both of those sublayers are going to be the ACSE, so ACSE, which stands for the Association Control Service Element, the ROSE, which stands for the Remote Operation Service Element, the CCR, which stands for the Commitment, Concurrency, and Recovery, and the RTSE, which stands for Reliable Transfer Service Element. All right, so we'll get rid of those ones. Now, those ones are going to be found in the case sublayer. Now, the ones that are found in the SACE sublayer, the SASE, are going to be the FTAM. So, the FTAM, which stands for File Transfer Access and Manager. The VT, which stands for Virtual Terminal. The MOTTR, which stands for the Message Oriented Text Interchange Standard. The CMIP, which stands for the Common Management Information Protocol. The JTM, which stands for the Job Transfer and Manipulation. Let me just make some more room because there's quite a few more for you guys. Now, we could go in depth with all these ones, but that would just take more time. This is just a basic knowledge of what is going into the sixth layer. But if we move on, we'll go ahead and go with another one, which is the MMS, which is the Manufacturing Messaging Service. Another one is the RDA, which is the Remote Database Access. And finally, the DTP. So this one is going to be the Distributed Transaction Processing. So basically, what the presentation layer does, it defines how two devices or two networks should encode, encrypt, and compress their data so that it is received correctly on the other end of it. So it works in cahoots with the fifth layer, the session layer, because it prepares the transmission for the session layer, and then the session layer, of course, does the rest. But a big thing is that the encryption and decryption could be found within this layer. So whenever you're doing like some kind of logging into banking, stuff like that, then the presentation layer will use the decryption to make sure that your session is still going accordingly. And that's it for the sixth layer, the presentation layer. Now we'll go ahead and go over the last and final layer, which is the seventh layer, the application layer of the OSI model. So the seventh and final layer of the OSI model is going to be the application layer. This is still within the host layer, so it would mainly deal with data. So basically, the application layer is used by end user software, much like web browsers, so Google Chrome, Firefox, Safari, those type of browsers, and also email clients. So you'll see that with Google, Yahoo accounts, other accounts like that. But it is used to allow software to send and receive information and data to the users. Now, some of the protocols that are found within the application layer are going to be the HTTP. Just write it down right here, which stands for Hypertext Transfer Protocol. The FTP, which stands for File Transfer Protocol. The POP, which stands for Post Office Protocol. The SMTP, which stands for Simple Mail Transfer Protocol, and DNS, which stands for Domain Name System. So a lot of those protocols that I just named off, you'll find a lot within like emails. You'll see a lot of those using POP or SMTP. But you also see DNS when it comes to like servers and stuff like that as well. But like I said, the application layer is pretty much the user interface that the user uses to get information as well as send information to different browsers and other such things like that. And there you have it. We went over the OSI model layers 3 through 7. So if you guys want to go ahead and check out layers 1 and 2, the physical layer and data link layer, go ahead and go back to my other video. But we went over the network layer, the session layer, the transport layer, the presentation layer, and the application layer. So if you guys like this video, go ahead and click that like and subscribe button below. And if you guys want more videos, stay tuned, because in my channel, we'll go ahead and talk about different networking things. But for now, this is all I have. If you guys found this video to be very helpful and useful, then go ahead and leave a comment below and let me know what you guys think. But right now, I'd like to thank Explain Everything platform. I'd also like to thank my other viewers and my sponsors that have always supported me. But until next time, guys, I'm Josh. See ya.